In this quick video, I want to just introduce enthalpy. Enthalpy is denoted by the symbol delta H. And what delta H means, enthalpy, is a heat exchange. So it's a transfer of energy in the form of heat. The units that we give delta H is kilojoules per mole reaction. So pay attention to that. That comes very important later on when we do further calculations. Now, enthalpy can be classified as either endothermic or exothermic. So I want to just kind of look at these two and compare and contrast them. If you have a reaction that is endothermic, we give that a positive delta H sign. Sign conventions are very important in thermo. If you have a reaction that is exothermic, that is a negative delta H sign. Now, what does this positive, what does this negative actually mean? Well, if you have an endothermic reaction, what that is doing is that it is absorbing energy. So endothermic reactions absorb energy. Exothermic reactions, on the other hand, are going to release energy. So exothermic, releasing energy to the surroundings. Now we have to learn a couple of terms here. You have a term called a system, and you have the term called surroundings. So what is the difference between the two? The system is what we are focusing on. So if we're talking about a reaction, the system would be that reaction. The surroundings would be everything else. So if you have an endothermic reaction and our reaction is the system, what is going to happen is that system, the reaction, is going to absorb energy. But the question is, where is it absorbing energy from? Well, it's going to be absorbing energy from the surroundings. If I have a reaction that is exothermic, and my reaction is my system, then what that's going to do is it's going to release energy. Now, where is it releasing energy to? Well, it's going to release energy to my surroundings. So what we have going on here is the conservation of energy. The total energy in my system plus my surroundings are constant. It's just transferring from one form to another. And that's what the first law of thermodynamics states. It says that energy cannot be created or destroyed. It's just transformed from one form to another. So the total energy in the universe is held constant. It's being transferred from either the system to the surroundings or the surroundings to the system. And depending on which direction it's going, that's how we classify if a reaction is endothermic or exothermic. Now, sometimes you have these reactions. So you'll have your reactants goes to your products. You'll have several different reactants there, several different products there. If you have an endothermic reaction, sometimes your enthalpy can be written in the reaction. If it's endothermic, your heat, your delta H value, some amount of energy, and how I know that is because it will be given the unit kilojoules, that amount is going to be written in the reactant side. So if it's endothermic, my heat, my enthalpy, is written as a reactant. If I have an exothermic reaction, what's going to happen there is that I can also have that enthalpy written in my reaction, but instead of it being written in the reactants, it's going to be written in the product side. So you'll have some quantity of kilojoules actually written in your reaction there. And if it's written in the product side, then that means that it is an exothermic reaction. Therefore, my delta H must get a negative sign. So heat is written as a product for exothermic. We also can look at whether or not we have an endothermic or exothermic reaction in graphs. So this is the graph that you'll be given. Let's say we have a graph here. On this side will be energy, and on this side it'll be reaction progress. So let me draw one for the exothermic as well. So energy, potential energy, and reaction progress on my x-axis. If I have an endothermic reaction, this is what my graph will look like. You have reactants and you have products. What I will see is that my reactants right there has a lower energy than my products, because what's happening is I'm absorbing energy into the system. Where I can find my delta H is I take the difference between my reactants and my products' energy. So it's products minus reactants. That is where I find my delta H value. Now, something to make sense of why this is a positive sign. If I take this product's value, which is greater in value than this reactant's value, I will end up getting a positive delta H quantity. And that's why we give the sign for endothermic as positive delta H. Now let me sketch a little graph for what exothermic would look like. Exothermic, I will have my reactants energy higher than my products energy. So reactants energy would be here, products energy would be here. Notice if I find delta H, so it's the difference between my products and my reactants energy. That's what delta H is. I have a smaller quantity of my products than my reactants. So if I take products minus reactants, I actually get a negative delta H value, and that correlates to the sign that we give for delta H. There's one more thing that I want to talk about, and that's referring to these reactants and products, and it also applies to delta H. Whenever I have a reaction, what I'm doing as a reactant is I'm actually breaking bonds. Breaking bonds. As my products, when my products are formed, what I'm doing is I'm rearranging and I'm forming new bonds. So as a product, we are forming bonds. Now, each process here is either an endothermic or an exothermic process. In order to break apart something, it requires energy. So if it requires energy, I have to put energy in to be able to break that bond. As a result, whenever I am breaking bonds, that is an endothermic process, so a positive delta H, anytime I'm breaking bonds. Now, when I'm forming bonds, what's happening there is my atoms are going from a higher energy state to a lower energy state. So if they're going to a lower energy state, that energy has to go somewhere. So what's going to happen is that energy is going to be released to the surroundings. And since I'm releasing energy, anytime I form a bond, that is an exothermic process. So you get a negative delta H. Now, to look at my overall reaction, in order to determine if my overall reaction is endothermic or exothermic, I've got to say, all right, well, am I forming more bonds than I'm breaking? Or am I breaking more bonds than I'm forming? Is there more energy required to break bonds than I'm getting out to form bonds? And depending on which side of the reaction is greater, that will help you determine if your overall reaction is endothermic or exothermic. So these are a couple of concepts that are really important to be able to start working with enthalpy. So I hope that helps a little bit.